Please welcome Yuval Bahar.
Good afternoon, everybody. Whoops. That's not good. All right. I'm here to talk about a technology called Open19. A little bit of background. I'm working in the data center group in LinkedIn, responsible for current and future generations of data centers. When we started the Open19 project, we looked at all of our locations from edge to data centers. And we said, okay, how do we optimize the future of our data centers when we have to scale significantly in the future, if we need to scale significantly in the future? That happened before the Microsoft acquisition. We had a certain trend that we were actually looking at, and we said, okay, we need to build something which is very scalable, elastic, and fast. You can call it a private cloud, but it's not really a private cloud because we're running a lot of our stuff on bare metal. We looked at all of our locations and said, okay, what is common to all of our locations? And we had at that time 4 data centers and about 6 to 7 large POPs and quite a bit of edge platforms. The only thing which was common to all of them was 19-inch rack. Nothing else. No power, no cooling, floating floor, concrete floor, dropping from the ceiling, dropping from the floor. Everything is different. Said, okay, let's try and find a solution that will actually address 19-inch as a baseline and take and extend it to all of our data centers. To do that, we had to do 2 things. We had to actually figure out what is the configuration that we want to go and set a set of goals. However, before we could start looking at the data center architecture in general, we had to actually modify and modernize our network. So the first step of what we did is we went to modernize our network to what we call a single SKU network. All of our networks, up to 150,000 servers locations, is built out of a single switch, one type of switch. It's a 1RU 3.2 terabit switch, and that's what we built on. Then we said, okay, let's build the data center around that. Okay? So we set up a few goals for our project. We said we want to create a solution that will actually take 19-inch rack, but will operate on compute, storage, and network. Second thing is we want to be operating in a very small environment and a very large environment. The smallest configuration we have is our Edge Connect platform, which is 16 servers, a switch, and a power management system. The biggest one is our Oregon data center, 150,000 servers, plus potentially can be there in that or location. Then we said, okay, we want to optimize the cost. We want to optimize the rack build-out and the insertion of servers into our data centers. And it's not the physical insertion. It's from the point that our apps team or SRE team come to us and say, I need another 5,000 servers. How long does it take us to actually bring them online? That is the cycle we wanted to shorten dramatically, and I'll explain in a minute why we wanted to shorten dramatically. And lastly, we wanted to create a consolidated solution. From our perspective at the time, we knew that we're not large enough. We were not one of the top 5. And for us to set the industry roadmap is very difficult. We knew we have to create a high adoption level, and for that we needed to create an ecosystem. So we created a lot of work and a lot of energy put into creating an ecosystem of all the companies which are interested in open source technology. To our surprise, even though we initially targeted just what LinkedIn needed, we found a lot of people outside which really loved what we were doing and trying to adopt it. And I'll talk a little bit about what we did to actually make it more strong in the industry. If you look at this, and by the way, a lot of discussions today were around software. My discussion is a little bit more hardware-oriented, so it's going to be a little bit different. We took a rack, a 19-inch rack, and said, okay, let's put in it 4 elements, which what you're seeing over here, the green ones, that we call cages. Those cages are a piece of sheet metal that all it did is setting up a form factor for servers. That's the only thing that happened over there. Then we said, okay, let's define different form factors of servers because we have different needs. Some of them are just Webbies, which are really light servers. Some of them are heavier. Some of them are storage servers. And then that leads us into another direction strategically in our data center that we treat everything in our data center as a server. From our perspective, it doesn't matter what it is. Every element in the LinkedIn data center is a server, which means it's provisioned the same way, it's monitored the same way, it's managed the same way. You say, how's that possible, right? How's a switch can look like a server? A switch that has a server inside, and most switches do have a server inside. It might be hidden from you sometimes, but there is a server inside. You just add to it a little component called BMC, and it looks like a server. It behaves like a server. It's just a server with a lot of ports on it, but it's still a server. So from a software management perspective, it looks exactly the same. A storage server, which we used to buy a lot, black boxes, all kind of configuration, what's in there? It's a server with a lot of drives next to it, which is running a specific application in user space. That's all it is. So it's still a server. So we went and said, okay, there's going to be a variety of servers. Let's define form factors for those servers. And we defined four form factors. We're showing over here 3. I'll show the 4th one in a second. Then we said, okay, let's optimize power and network. Optimize power by creating a central power distribution. We created a power shelf, which is doing a very optimized way of distributing power. We decided to distribute 12 volts, and people ask, why not 48? Because 48 is not something which is available in the industry in any motherboard. Every motherboard in the industry is 12-volt base, so you're better off distributing 12. And we created a specialty switch, which will optimize the way we interconnect. If you look at the picture over here, you don't see cables, right? This is a data center rack full of servers with no cables in it. And I'll show in a minute how we did that. We did on the backside something special. We took that thing, which we call snap-on cables, and we created like a cable plant for power and data. We gave 100 gigabits per second for every brick, what we call a brick, which is a half-width server, and created an environment where it grows linearly, which means if you're double wide, like a standard 1RU, you get 200 gig. We set up 400 watts for every one of those servers, and if you're double wide, you get 800. If you double high, which means the 2U solution, you get 4 times the capacity in power and data. Those elements were actually really easy to implement because they reflect an environment like a chassis, but it's not really a chassis. But what it did for us, it actually did for us a blind connectivity for all of our servers, which means that when we insert the servers into the data center, all we need to do is push them in. We push them in. The automated system actually jumps on that, takes it, brings them online, and that goes back to our goal to how quickly we can actually build new data centers. Okay? This is a real-life picture just to show that this is not just diagrams. What you see on the left side is the first demonstration that we did for this live. You see a cage on the top, which actually has 5 different suppliers of servers in it. It has HP, Flex, Inspur, Supermicro, and a LinkedIn design server, all coexisting in the same chassis, working together on the same network. It's the first time in the industry that all those guys are actually willing to work together in the same chassis, because usually when you buy a chassis to data center, it's my servers, and only my servers. You'll never be able to put other servers in there. This is the first time that this group actually did this, and we have many more of doing this. What you see on the right side, and I apologize for the ugliness of the cable, but this is our first prototype. You see the cables, which are the snap-on cables. What you can see on the front over here is all you see is a flat front of a chassis, which has servers plugged into it. And that's the way that Open19 it is. In general, if you look at this, this is Open19. So you say, okay, where's the server? Why didn't you put a server in here? And we did this on purpose by design. What we did, we said, okay, all we define is a form factor. We don't define the inside of the server. Unlike other projects which are open source projects, where large companies come and say, here's my server. If you want to use it, go use it. But it's my server, and I designed it for my needs. All we did over here is say, here's a form factor. If you want to design a server that I'll buy afterwards, design it. That's why we get people like HP Enterprise, people like Inspur, to come in and say, okay, this is my innovation platform. I can now differentiate myself. And if you are a small company, which does not have the resources to run your own management, etc., you go and buy from HP, and you get the warranty model, and you get the support model from HP. But if you're savvy enough to actually control your own environment, you just buy bare metal from whoever you want. If it's Inspur, or Supermicro, or anybody else who are actually going to sell those servers into this environment. If you double click just one level down, this is the cage which goes into every rack. It's a piece of sheet metal, relatively low cost, and it doesn't have a strong impact on where we are from a build out of a data center. If you look at the cost of building a data center, where is most of the cost? It's in the servers. The servers are carrying more than 95% of the cost of building data centers. The racks, the power, the network gear is like on the 5 to 7% of the cost of data center. So what we did over here is say, okay, let's modify the rack to be able to take that thing in, create modularity on every 2U when you can take either 4 small bricks, which are half width, 2 double high, 2 double wide, or something weird, which is double high, half width. And we did that form factor for designs which have modules in them, mostly GPU designs, which have a lot of modules in them and want to actually stick high, but they don't want to be wide. So that's why we did that. And then we say, okay, let's put snap cables in the back. What you can see over here is just a hole, right? There's nothing in there. Now that helps us dramatically with the way we build data centers. Because we use, traditionally when you buy space and you go build data center, what do? You're rolling in racks, either with servers or without servers. You do the integration of the servers to the rack, offsite or onsite, doesn't matter. And then you bring them online, and it takes some time to do that. If you do offsite integration, it takes time on the offsite side to actually do the integration. You roll them in, you can roll them in very fast. For LinkedIn, we used to do on-site integration. So for us, it was very important to actually break down the way we build that. What we do today is we roll in racks which are empty. We put those cages in pre-installed. So before we have a single server in our data center, all of our data center is ready with empty slots. Okay, that's all it does. It costs us a fraction of the cost of building a whole data center. But the huge advantage that we have right now is that when we bring in the servers on demand, it takes minutes to actually load the full rack, because all you need to do is push the servers. And you also can actually take your technicians to a lower level and say, you don't need to understand anything. Put the 5 blue servers on slot 1, 2, 3, 4, 5. The red one over here, go away. The network operating system and management will actually take it from there. Identify the system, identify the servers, load them up, start them up, put them up with the latest operating system, and enable them to the SR18. This cycle used to take us between 12 and 18 weeks to do. We expect when we do that now, it's going to take us days to do, which is a huge advantage for us also from a financial perspective. Because if we had to buy servers a quarter or 2 quarters ahead of time, we would pay prices for memory, for disk drives, which are 2 quarters back. In today's dynamic market, paying for SSD 6 months ago and paying to SSD today is a very, very different price. I would like to pay the price of today, and not today for 6 months forward when I'm actually going to be able to get something out of the server. When we reduce the cycle of the integration to days, then we actually can buy today what we need today, which is a huge advantage for us. If you look at the form factors that we built, like I said, 4 form factors: brick, which is half width, double high, half width, double wide, which is a standard 1RU, and a double high, which is 2U. 2 things to take out of this is linear power and data growth, which means the bigger you are, you get more power and more data. Where the baseline is 100 gig to the smallest one, and then you jump to 200 and 400 gig on the larger events. And the second thing is self-sustained. And that goes to a very basic concept of what we're doing, saying everything is disaggregated. I don't want to operate on a rack level. I don't want to operate on a chassis level. I want to operate on a server level. All of our data centers, if it's 15 servers, 16 servers, or 100,000 servers, doesn't matter. It all operates on a server level, which means that the server in slot 1 should not be aware of the server in slot 2. And if we define that those servers are self-sustained from a cooling and EMI and safety perspective, that means that I can put an HP next to an Inspur, and they will coexist. And if I have certain apps which actually requires certain type of servers, I'll put them in. But then next to them, I can put servers which are completely different. And that will still be completely OK because they're self-sustained. Okay? They have blind mate connectivity for 100 gig base and power, like I said, 400 per. We took a PowerShelf and we said, OK, we built a generic PowerShelf. This is the only element which is very centric to a rack level or to a zone where we have 48 servers. Oops. We said, OK, 1RU, 9.6 kilowatts is a good zone for data centers. We can put 2 of them in a rack if we need to. Full management through Gigi. There is a server inside this PowerShelf. Like I said before, everything for us is a server. This PowerShelf is also a server. There is a server inside which is running Linux, and we can actually provision it, monitor it, do everything like it in that shelf. That shelf is completely universal. Any input, DC or AC, any type of input, single phase, 3-phase, high voltage DC, whatever you have, it will take. With multiple sources for them, and doing something very special over here compared to other solutions which doing central distribution is we're doing per server protection and monitoring. And it goes back to aspect of disaggregation. If the server in slot 1 is shorting, I don't want it to impact the other 47 servers which are actually in its zone with it. If you do it through a bus bar distribution, one short, all 48 went down. If you do it independent protection and monitoring, then you can monitor and protect and serve each one of the servers separately. Let's talk a little bit about the benefits. Any 19-inch rack in any location, doesn't matter where it is. If it's your location, if it's a colo location, if it's an exchange, doesn't matter. 19-inch is always there. Fully redundant infrastructure. Fully redundant infrastructure. If you look at the infrastructure over here, what's the infrastructure? It's the PowerShelf. That's the only infrastructure. The rest of it is just bare metal, sheet metal, right? Full disaggregation. All the servers in the environment over here are self-sustained. Very, very short integration time. We can integrate about 6 to 8 times faster. And you'll see some of our partners in the Open19 platform are people who do integration, integrators, like Grouper, for example. They see this attractive because it makes them much more efficient to actually integrate this. It doesn't actually need to be just the end users which actually get the benefit. Even the integrators which are doing off-site integration get a benefit out of this. We're leveraging existing servers, and that's very, very important to us. When we started the project, we went to all the server suppliers and asked 2 questions. What's the size of your motherboard, and what's the power your motherboard is taking? And we got one answer very clear. Everybody said 12. So that was an easy decision for us. And then we collected the dimensions of all the motherboards of the existing servers, and we made sure that when they define the form factor for Open19, they can drop it in as is. All they need to do is add an adapter in the back to connect to blind met connectivity. That's all they need to do. That's why you will see a very strong trend and a very strong availability of components very quickly, because nobody needs to actually go and design a new server to make this thing work. Very power efficient, single stage power conversion, over 96%. You won't be able to get better than that because you feed the motherboard directly from that solution. And cost effective on all aspects of that, from the time that you can buy and insert the servers to how quickly you can bring the servers online. Okay. Deployment model that we've seen, traditional deployment models are just data centers. We're seeing a new emerging deployment models of what we call bare metal cloud services. It's not the bare metal that you talked about before. It's actually companies like Equinix that come and say, why should I just rent the building? With this solution, I can actually rent the slots. So they put the racks in, they put the cages in, and start leasing slots instead of leasing data center space. There's a very big data center in Norway right now called Lefdal Mine. If you haven't heard about it, go check it out. It's very cool. Their model is actually deploying exactly that. They will deploy empty slots in the data center and start leasing slots and not leasing space. High efficiency off-site integration we talked about. And lastly, that's probably one of the most important aspects of this. Since we can shrink this to a very small environment, all the edge platforms that we've seen for cloud, which are emerging right now, and at least my humble opinion, will take over the 5 mega data centers in the next 3 to 4 years from the capacity of how many servers they're going to have in there, are actually fully optimized for that. They can take a very small footprint, leverage the value which you have in the very large data center, but still do a very small footprint for that. Let's talk about the foundation. So when we started the project, we said, OK, it's open source hardware with some open source software. Let's contribute to the generic open source environment. it was very difficult for us to actually convince our ecosystem partners to go into the existing environments because they're very restrictive and very, very strong on IPR sharing. So we went and developed a new foundation which enables people to come in and be either observers or contributors, but the restriction on what kind of IP you have to contribute is actually up to you, and it's not up to somebody else. We launched it at the end of May, and the community is basically coming around open source hardware and software. Open19 project is just one of many projects that we have in there. We have currently 5 founding members, 15 fully registered members companies, and about 1,200 individuals. And we have in the pipeline another 15 companies which are actually right now in the process of joining the company. Just to put in perspective, we're about 11 weeks from announcement. So it's a very large number of companies which are involved in that. We're in the final forming stage. All the IP rules and the community are actually set. If you're interested to join as an individual or as a company, just go to open19.org. So in summary, Open19 is about defining a form factor, not telling you how to build your server. Build your own server, or go buy a server from HP, Inspur, Quanta, Supermicro, or Cisco. It doesn't matter. The form factor is common. You build once the form factor, then you do reverse bidding. I have 1,000 slots that I need to fill. Who wants to actually sell me a server to that slot? That's the way we operate. It's about the community collaboration. All of this that you've seen is going to be completely contributed to the organization and reproducible. Which means that if something is contributed to the organization, somebody can go and take it and put it in the hands of your favorite ODM and say, build it for me. And they'll be able to build it. Okay? We currently have over 75 companies involved in the project itself, not the foundation, which are actually contributing to the discussion, contributing to the development, contributing in ideas, contributing in time and in money to make it successful. It's data center operators and integrators, system suppliers, and component suppliers. We will be ready end of Q3 for production, which is very, very close. It's about weeks away from us. And like I said, if you want to join, just go and join. If you have more questions about it, I'll be happy to answer. With that, I'll close. Thank you very much.